This is a logistic equation. You all see that. The very first question says, if t of 0 is 30, when is this growing the fastest? If it asked you what will the population be when it's growing the fastest, what will the population be when this thing's growing the fastest? Half of 5,500, right? 2750. Cool. It'll be growing the fastest when p equals, come on, 2750. But that's not what they asked. They didn't ask what, or I didn't ask what the population was. I said when, which means we need to know when, what time this is going to happen. Okay? So we need to set up an equation to solve for time. I need to find out when will p equal this. So I need an equation for p. The equation for p, because it's logistic, is easy. It's the carrying capacity, which is 5,500, over 1 plus a e to the negative. So this, we need a calculator for this to calculate all this out, right? But we got to do m times k. Here we go. That's negative, what, 0.3 times 5,500. Badoom. 1650. Okay? But I need to know what A is. I gotta find A. The way we find A is by plugging in the point we were given. Okay. Look. We gotta find A here, okay? We gotta find A. We do that by using the point we were given. Okay? We can do it off to the side here. I need 30 to equal 5,500 over 1 plus A. Does that make sense? Yes. Oh, yeah, there should be a T on there. Thank you. Sorry, I lost track of what I was doing there. Does that make sense? That's how we find A. You plug in the point and you solve it. A lot of times it works out super nice. This, we're going to cross multiply a little bit here, and you get that A is, you got to divide 5,500 by 30, and then minus 1. Okay? Nope, minus 30, right? Good call. Okay? Whatever 55 over 30 is, it's going to be a decimal, but let's just do it. 5,500 divided by 30 minus 30. Boom. Let's go ahead and make that a fraction just so it's a little bit easier. 460 over 3. Does everyone see what we did to find A? You got to be able to find A for this question.
Are you ever going to give us, not 0, regular 1?
I could. I mean, I could. You have a calculator to solve it, so you can solve it like that graphically, okay? I don't know. But what was it, 460 over 3? Yes. Yes. Oh, yeah, that should be a 1. Ah, I knew it. Someone said 30, and I put a 30 there. Oh, God. Kids, you're just like talking nonstop. There's like always constantly like 5 people speaking in this room. And I get, so like, I'm just trying to find out what we did that, but then you miss what we're doing now, and then you're talking like, I don't. Okay. This should be a 1, basically, is all I'm saying. That 30 should be a 1. Yes, yes, yes. Okay. Which is what I had initially. I heard someone say 30, and I had a brain something. Okay. Yeah. Kaboom. All right, so this isn't 460 over 3. It's something different. 547 over 3? Great. My favorite number. Okay. Are y'all with me here? Good. You look great. So, we got to solve this equation. You have a calculator. Just do it on there. You know what I'm going to do? I'm going to graph it. It's 5,500 divided by 1 plus, what is it, 547? Divided by 3. E. Huh? Oh my gosh. Thank you. Second insert, divide There you go. Right? To the negative 1650 x. And close that off. Since I want it to equal 2750, is that what it was? I'm just going to do minus 2750 and see where that hits 0. Okay? I have no idea when this is going to be, so I'm going to change my window to go from, I don't know, 0 to 50 maybe. Okay? And why I'm always let be negative 1 to 1, because I just want to see where it hits 0. We've done this a bunch of times. I'm going to graph it. Hopefully it comes through here and hits it somewhere. You can do it. It didn't happen. We got to change the window. Let's go out to 200. Okie dokie.
5,000.
Well, let's keep going further out. Yeah. I don't know where it's going to happen. Let's go out to 2,000. Why is it not happening? Did I put it in wrong? 5,500 over, parenthesis, 1 plus 547 over 3, e to that, close that, minus 2,750. That's right. Am I finding it yet? Why don't we have this yet? It's not going to take 20,000 freaking years.
Oh, Smith,
What?
in your y equals, I think it's multiplying the 3 times the e.
Yeah,
I think that's
I think
going
it's
on.
the zero, the 1, and the 547.
Yeah.
No, that's right. The calculator knows that's 547 divided by 3.
No, but you're putting the e on the bottom.
It's not.
No, I mean, I did that in Excel.
Yeah. Can we finish this, please? Can we finish this, please?
Yes, we can.
We can try.
Yo, all that happened was that it grew very quickly, okay? I didn't expect that. I'm not exactly sure why. I think my K value, 0.3, is just way too big. All right? I think generally it has to be smaller.
Like smaller than 1? Like 1?
I just made this up. It really doesn't matter. I just made this up. Huh? Oh, well, we got to find it now. So look. Yeah, it's a very tiny number, but we want it to equal 2750. Again, this was not complicated for any particular reason. The graph just looked a little different than I expected. It's okay. We got a good window for it. It's still a logistic curve. I'm going to graph it. You see them intersect, okay? In general, this would have taken more time. That's all. It happened super duper quick. I told you, I just changed the numbers. I didn't run through and double check all the work. I should have made it smaller. Doesn't matter. We got to find where this intersection is. Boom, boom, boom. And you get t equals 0.003. Do we get the basic gist of what we just did?
Yeah.
Okay? That was not crazy complicated. It's all a lot of the same math we've been doing. But you're going to write, my pen is dead. So you're going to write t equals 0.003. Okay? What units are we on here? It doesn't say. So we don't know. But I mean, it could be minutes, years, whatever. With 0.03, let's say it's in centuries. I don't know. Okay? So yeah, I didn't give you units. If you had units, you got to put them on here. But it's 0.03. As p goes to infinity, I hope you all know, this goes to 5,500. The derivative goes to 0. Okay? And that's it. And the last thing we got to talk about is this cup of coffee thing. Nope. Yep. So, it said, and we talked about this, the general idea behind this is that the rate of change of the temperature is proportional to the difference between the temperature of the coffee and the temperature of the room that it's in. It's in a room that has a 68 degree Fahrenheit temperature. So, it's going to be 68 minus T. That's the basic idea behind it. That's a very basic differential equation. Okay? We're going to solve it by separating and integrating. You're going to get this. If you integrate both sides of this thing, you're going to get the negative ln of 68 minus t is equal to kt plus c. All right? Okay. Then we got to solve for t. So we're going to divide by a negative 1, and we're going to raise it to e. So you get 68 minus t must be equal to e to the negative kt. It should be minus c there, but we always just put like an a out front, right? Is that okay? No, we just find A. It's fine. Also, these absolute values are still here. What's the absolute value going to do to this thing? If I plug in a temperature of 100 and whatever it was, 95, it's going to change its sign, which means 68 minus T would really become T minus 68 or negative 68 plus T. Same thing. Okay? And then we're going to add 68 over. So the temperature must equal A e to the negative KT plus something. 68. Yeah, that makes sense. Okay? And then we got to find A and K. But I gave you the initial temperature was 100 and something. What was it? 95? So when you plug in 0, you got to get back 195, which means A has to be. Any takers? Oh. 127. Cool. Because when you plug in 0, it has to equal 195. And then we're going to use the other point that we were given to find K. Because we really want to know what's the temperature after 18 minutes. Okay? We know after 12 minutes, for some reason I happen to know the temperature is 143 degrees. Which is probably way too hot. This isn't some kind of thermos or something. Okay? What's up?
Why did you get T minus 68 again?
Because if you plug in 95 into here, you're going to get a negative number, and the absolute value is going to change that sign. Okay? And we can't cross 68, so the absolute value will always be changing its sign, which means it's always just going to flip it. Okay?
But why don't we change like the A to like a negative?
Well, you could, but I'm just going to, when you solve for A, you're going to get a value. Okay? That's all. So, we're going to plug in, I forget what it was, grab that for me for a second. You plug in, what, 12 minutes, you get 143 degrees. So 143 must equal 127 e to the negative 12k plus 68. Okay, they look for someone else. Oh, great. Are you in trouble? Good. Expulsion. Minus 68 off of here. What's that going to leave us with? Anybody? Anybody? 68, 143, minus 68? 75. And we're going to divide that by 127. That's going to equal this. We're all paying attention. We're going to natural log both sides and divide by negative 12. Negative 112 ln 75 over 127 equals k. And since we're blessed with the calculator on this event, okay, well, we're actually going to find the approximate answer, which is weird. Negative 1 divided by 12 times a natural log of something. 75 over 127? Kaboom. Sound good? 0.0439, we'll say. 0.0439. Boom. Yep. So, all that means is when we come all the way back up here, this is negative 0.0439t. And the question specifically said, what's happening after, what, 18 minutes? So we got to plug 18 into that dumb thing. That's not too bad. 127 e to the negative 0.0439 times, how many, 18?
Yes.
Thank you. Kaboom, plus 68. The temperature is still a nice warm 125.627. Okay, and you just write that over here. T of 18 is 125.627 degrees Fahrenheit.
6.2.
Huh? 627? Boom.